Hello everyone, today we're going to solve one problem about thermodynamics. So here PT graph, and we should find the total work of this in these processes. So firstly we need to draw this line to find an angle. Here angle tangents alpha. So we can draw this point to find the T and P. We can write it. So let's start to find an angle tangents alpha equal to, here we determine this side, tangents alpha of this side. So here we can write it T0 here. So here will be 10 to the power of 5 divided by 100 minus T0, right? And then the second part is here tangents alpha is also tangents alpha equal to this side divided by this side, right? Here P divided by T minus T0, right? And then big triangle, big right triangle, we should find the tangents. We should write the equation of tangents alpha of this part. So here will be 2 times 10 to the power of 5 divided by 300 minus T0. So we can this tangents alpha is equal to each other, so we can write it by this way: 10 to the power of 5 100 minus T0 equal to 2 times 10 to the power of 5 divided by 300 minus T0, right? So we can find it T0 here easily. So let's write the result of calculation. Here will be minus 100 Kelvin. So we found the T0, and we can write it tangents alpha's equation by this way. So here will be 100 minus T0 equal to P divided by T minus T0, right? And then T0 is equal to 100 minus 100 Kelvin, and here will be 200 equal to P divided by T minus T0 is equal to 100, right? Here will be plus 100. So here we can find it pressure easily. So here will be 10 to the power of 3 T plus 10 to the power of 2 divided by 2. So we found P, pressure, by T. We found the equation of pressure by T, and here we can find the T, temperature, in this equation. So here will be T equal to 2P divided by 10 to the power of 3 minus 10 to the power of 2. So we found the equation of temperature by P, and we can write it in ideal gas law, nRT. So here this equation we put it here. So here will be PVNR 2P over 10 to the power of 3 minus 10 to the power of 2. So here will be PV, then 1 831 2p over 10 to the power of 3 minus 10 to the power of 2. So here we can find the p equation of p. Let's write the result of calculation. P will be equal to 831 divided by 1662 divided by 1000 minus v, right? So we found the pressure by v. We found the equation of pressure by v. So we can find the work in 1, 2 from point 1 to point 2. So let's find the 1, 2. Here will be v final, v initial, and pdv. We pressure, instead of pressure, we put this equation. So here will be 1000 minus v, right? Minus v, and dv, right? dv. So v final and v initial, what does it mean? And v final, it is here, we can write it v2, and here v initial, right? v1, that's right. And here v3 is also need us in the features equations. So let's find the v1 equal to, we know that from ideal gas law, nRT1 over P1, right? So all these values are given. So let's write the result of calculation. So v1 equal to 0.00831 meter cubic, and v2 is also nRT2 over P2, right? So here let's write the result of calculation, 0.01246 meter cubic, and v3 also nRT. T2 is not changing, right? T2, and P1, here will be P1, right? The last volume here, P constant, P1 here, and T2 is not changing. So let's write the result of calculation. Here will be 0.02493 meter cubic. So we found the volumes, so we can put it here. Volume 1 will be here, V initial, and volume 2 will be here, right? Here, because V2, it is final volume in this process, right? Here in this process, 1 and 2. So 1 and 2, 0, 0, 0, 12, 46. Here will be 0, 0, 831, and this equation, right? 831 divided by 1662 divided by 1000 minus V, and here will be dV, right? So it's also easy. We know that from calculus. Here will be integral, and let's write the result of calculation. So here will be approximately 575 joule. So here we found work in this process, in this situation, and let's find in this site, right? Here is isothermal process. Temperature is not changing. So let's find it. 1, 2, and 3. So we know that from thermodynamics or work in isothermal process, it is equal to nRT ln natural logarithm v final over v initial, right? So all these values are given. 831 times t is not changing, 300, and times here v final will be this v3 it is here 0.02493, and divide by v initial it is here, right? v2. So v2 is equal to 0.01246. So here will be, let's write the result of calculation, 1729 joule. So we found the work of 2, 3, and let's find the last part, 3, 1, right? 3, 1, it is isobaric process, pressure is not changing, so we can write it simply PdV, right? P is not changing, 10 to the power of 5 times V delta V. Delta V, it is V final, V initial. Final volume is here, and the initial volume is here, right? So we write it here, V1 minus V3. So 10 to the power of 5 times V1. V1 it is 0.0831 minus V3, it is 0.02493, right? So let's write the result of calculation. Here will be minus 1662 joule approximately. So we found all this work in each site, in each situation. Here 1, 2, 2, 3, and 3, 1. So we can find the total work. Total work equal to 1, 2 plus 2, 3 plus 3, 1, right? So 1 and 2 equal to 575 joule plus 2, 3, 1729 plus this number, right? This is minus, so here will be minus 1662 joule. So here will be approximately 642 joule. So we found the answer. We found this answer, total work, is equal to 642. Thank you for your attention.